Okay, try this again. Okay, let's see. We're evaluating 4 tan negative 11 pi over 6 plus 2 secant negative pi over 4. Well, the 4 is 4. What do you think about negative 11 pi over 6? So negative 11 pi over 6, if I go ahead and add 2 pi to it, you're adding 12 pi over 6, which puts us at pi over 6. Well, that'll be a nice one to do, right? 4 times the tangent of pi over 6. And what is the tangent of pi over 6? Square root of 3 over 3. So we're going to be doing 4 times square root of 3 over 3. Plus 2 times the secant of negative pi over 4. Do you really need to convert this out of negative? Not really, because where's negative pi over 4 going to be? It's going to be right there, isn't it? That is negative pi over 4. If you want, you could call that 7 pi over 4, but I don't really need to know that it's 7 pi over 4. I need to know what is that reference angle. And what is that reference angle? Pi over 4. If I went negative pi over 4, I went pi over 4 down from the axis, didn't I? So that's one where I wouldn't even necessarily think about the 7 pi over 4. The other one, I was more in between. This one, yeah. If you guys were comfortable with the last one, you're probably comfortable with this one. So I'm just going to leave that as 2 secant negative pi over 4. What is the secant of pi over 4? What'd you say?
2 over square root.
Okay, so 2 over square root of 2. If you flip the rationalized version, you get 2 over square root of 2. What was it? What about if you flip the unrationalized version? Right. Does that make? Do you see what I'm saying there? The fact that square root of 2 over 2 came from 1 over square root of 2. This is the one time I like using 1 over square root of 2, because what happens when you flip 1 over square root of 2? It's just square root of 2. And is that a positive or negative? Yeah, secant is reciprocal of cosine. We're in the cosine quadrant, so it's positive. Did I ask about the last one if it was positive or negative? Oh, it was quadrant 1, so. Okay, I'm going to write this as 4 square root of 3 all over 3 plus 2 square root of 2. You could get a common denominator and put that all over 3 if you wanted to, but you don't have to. As I said, this is one of those things. We're reviewing it because this is a necessary part. Do we use trig in all calculus? No, by far not. It randomly pops up. Okay, we might use trig for a couple of days. We might not use it for a couple of weeks. Who knows? It's not something you just always use. So, okay, using the trig ratios to simplify expressions into sine and cosine. Okay, so that's what we're being asked to do here is into sines and cosines. Just remember, one of the things we talked about last year, everything can become sine and or cosine. Okay, everything go to sines and cosines. So remember, tangent is sine over cosine. Cotangent is cosine over sine. And we've already talked about the reciprocals. So, simplify. You guys didn't really like the simplifying, but if I tell you everything goes to sines and cosines, there's your huge hint, isn't it? What do you know about cosine squared theta? Cosine squared theta. Knowing what I know, I'm going to go ahead and make it it's reciprocal of cosine, so 1 over cosine theta. And now you see why I went ahead and went fraction route, right? What do you know about tangent? Sine theta over cosine theta. Yep. You have a cosine squared on top. On bottom, you have cosine times cosine. So all cosines will be gone, and we do end up with sine of theta. Okay. Cotangent. What do you know about cotangent? It is cosine over 1. And then this is technically all over cosecant. What do you know about cosecant? It's 1 over sine. Now, I basically just recopied the problem. I'll be honest. If I was doing this on my own, I would have skipped to the next step. How do we divide when fractions are involved? Multiply by the reciprocal. So that means we're going to keep the numerator and we're going to multiply by the reciprocal of the denominator. So honestly, I would have gone ahead and skipped to that next step if I was doing this on my own. So it's going to be the cosine over sine times the cosine over 1. And then instead of dividing by 1 over sine, we're going to multiply by sine over 1. Any good cancelings? Sines cancel. And then that leaves us with cosine squared theta. Options on how to write cosine squared theta. I usually write it like such. Cosine, the squared, and then the theta. The other alternative is to do cosine theta, parentheses, quantity squared. That is equivalent. What you cannot do is you cannot put the squared after the theta but no parentheses, because then it's directly on the theta and it's just squaring the theta instead of the whole trig function. Okay? Last year you guys thought this stuff was horrible. Is it somewhat better now?
Oh, it's better than the stuff we were doing.
You feel like you've learned this lately. Okay. Obviously, homework to go with that is problem set 4. It can be found on page 20. And sorry, I'm lazy. I don't ever write the homeworks down because it was lesson 4. So you're doing problem set 4.